Solving and simplifying using trig identities. This is a video that I've been putting off making for a little while, and the reason for that was because I couldn't come up with a really nice, neat way to teach it. And I've been thinking about it for like a few days now, going, how am I going to make this video? How am I going to make this video? The truth is, there is no nice, neat way to go about this trig identity stuff. You really need to be a bit creative, and you need to put a little bit of effort into it, and you need to be willing to make mistakes, because often you'll go down the wrong path and you'll have to backtrack and try something different. Okay, so first of all, we need to deal with what our trig identities are. There's two basic ones. Sine squared theta plus cos squared theta equals 1. So that's one of the trig identities. The other trig identity that you'll use is sine theta over cos theta equals tan theta. Now, these trig identities can all be rearranged, obviously. So you could also say that sine theta over tan theta equals cos theta. And although you wouldn't use this one that often, you could also say that sine theta equals cos theta times tan theta. So just to, and then this side as well, you could also say that sine squared theta equals 1 minus cos squared theta. You can see I've just rearranged that by moving the cos theta over there. And you can also say that cos squared theta equals 1 minus sine squared theta. Now, it's important, particularly you'll find that you use these quite regularly, and you'll find also that you use this quite regularly as well, and you might use this a little bit as well. Let's give you an idea of some of the sorts of questions that you might be able to solve using these trig identity type things. Before I do that, I probably just need to draw your attention just to one more. It's related to this one here. If sine theta over cos theta equals tan theta, then it must be true that sine squared theta over cos squared theta equals tan squared theta. So there's another one, and that's actually a pretty useful one. You might find yourself using that quite a bit because it's got those squareds in there. So you might find that you end up using this ratio, this trig identity, along with one of these trig identities. Okay, so 1, 2, 3, 4, 5, 6, 7 of these, but they all stem from these particular ones. So as long as you remember 2, you can rearrange them to make all of these other things. So one of the things you might get asked is to prove something. So in this particular case here, you can see that I'm being asked to prove that cos squared theta minus sine squared theta is equal to 2 cos squared theta minus 1. Now, in these particular cases, the way to prove things, this is probably something you haven't done a lot of before. If you want to prove something, the best way to do it is to break this up into left-hand side and right-hand side, and then start dealing with or manipulating one of the sides until it looks like the other side. So I'm going to manipulate the left-hand side until it looks like the right-hand side. So let's do the left-hand side. Cos squared theta minus sine squared theta. Now, looking at my right-hand side, you can see that my right-hand side has no sine squared theta in it. So this sine squared theta is the thing in the way. Now, how can I get rid of that? Now, looking through my trig identities, I can see that sine squared theta is also equal to 1 minus cos squared theta. So I'm just going to replace that. I'm going to replace sine squared theta with 1 minus cos squared theta. Now remember, it's minus 1 minus cos squared theta. So you can see I've just replaced that with that. Now when I remove those brackets, it's going to be minus 1 plus cos squared theta. And you can group cos squared theta, cos squared theta. That'll be 2 cos squared theta minus 1. So you can see through the simple manipulation of the left-hand side and using our trig identity, we've now shown that the left-hand side can be manipulated to look like 2 cos squared theta minus 1, which is what the right-hand side was. So I'll just finish off by saying, therefore, left-hand side equals right-hand side. So these two things are equivalent because I could use my trig identities to manipulate it to make it so that it look like that. Let's just try another one we can do. Now you might get asked to simplify something. This is a really, really simple one. The square root of 1 minus sine squared theta. Now we should recognize that 1 minus sine squared theta, according to our trig identities, is equal to cos squared theta. So we can say that that's equal to the square root of cos squared theta. And finally, this is cos squared theta. Don't forget that that's cos theta all squared. So the square root of that is just going to be cos theta. Now I would argue that that's plus or minus cos theta because we've found the square root of that. It'll be plus or minus cos theta. So that's a second use for our trig identities. Let's do something really complicated. We're going to pull up there actually with our trig identities. There will be another video available with some more complicated questions here, but really what you need to do is start looking at these and practicing them. I've shown you what a proof looks like somewhere. I've shown you what a proof looks like here. You also might get asked to simplify things. You also might get asked to solve things. We're not going to go through that in this video. But basically, you might get something really complicated looking and you'll have to simplify it until it's of the form, you'll have to simplify it until it's of the form like cos theta equals 1/2, and then you'll solve it using your unit circle again. But I'll give you a bunch of questions so you can try them out yourself. Alright, that's solving and simplifying using trig identities.